Welcome to the course on Introduction to Basic Mechanical Engineering. We are now going to get into the second part of this course. In this course, our primary focus will be manufacturing. Manufacturing is a wonderful area wherein which what you feel, what you think, if you could get it converted into a physical part, nothing better than that. You get so much of satisfaction when you try to manufacture of your own and try to see a product which can be a small functional oriental product or aesthetic product. So, manufacturing is the focus of this course for the next 30 hours. The content of this lecture is going to be a basic small introduction, then manufacturing. How did manufacturing evolve over a period of time? What are the classifications of manufacturing, that is constant volume methods, material shaping deformation, material subtraction, material joining, polymer molding methods, materials addition, and finally, we will try to see a recap. Manufacturing. Manufacturing refers to a process of producing goods through the utilization of equipment, labor, machinery, tool and various other chemicals or biological methods of processing or formulation. So, it is a process of producing goods. These goods are which are useful for human mankind. We are not asking you to produce it only by manpower. We are also trying to involve equipments, machinery and tools. So, manufacturing is not exactly focused towards only mechanical manufacturing. You can try to produce any output. For example, cooking. Cooking is also a manufacturing wherein which you try to produce a food using utensil, using a spoon, raw material, there is a temperature or there is a pressure or there is a shearing action, you convert it into another form and present it such that it is more attractive. Manufacturing is a process of producing goods. Manufacturing is the field of engineering which is focused on design and optimization of manufacturing process. You can do a particular product through various outputs, various processes. So, trying to choose the best process in terms of energy, in terms of quality, that is what is optimization of manufacturing process, which involves the transformation of a raw material into a finished good. Taking 1 kilo of a material and trying to produce one piece is not manufacturing. Trying to produce the maximum output with minimum wastage is optimization of manufacturing process. The process initiates with the design of the product and specification of the material. The next lecture which we will do, we will try to understand material such that the manufacturing process you can properly choose. Subsequently, the material undergoes modification in terms of shape, size, heat treatment. So, all these things, for example, a finger chips, whatever you do, you quench it in oil and take it out. That is modification of the surface, surface becomes crispy and the core becomes soft. So, undergo modification during manufacturing to achieve the intended physical product. So, manufacturing is producing the goods from the raw material in an optimized fashion using minimum energy, minimum manpower and minimum material. Today, when we look into automobile industry, you see there is lot of automation happening and we use lot of robots which are used. These are the bottom ones, these are fixtures to hold and these are robots which can help in welding, assembly, whatever it is. You can see here another type of robo which is used for pick and place and weld. So, these are nothing but machineries which are used, equipments which are used for holding, but producing the output which is consistent, reliable and repeatable. The manufacturing is not started just now. It has a history. The human ancestors created tools from stone and the other material well before the appearance of Homo sapiens approximately 2 lakh years ago. They realized that the tool which is used for sharpening a stick or a softer material should be harder, and there has to be a geometry given to the tool. So, creates a tool from stone and the other materials. The oldest technique for producing stone tools refers to as Oldovane industry, which traces back to 2.3 million years ago, with the earliest concrete evidence of tool used discovered in Ethiopian Great Rift Valley dated 2.5 million years ago. To manufacture a stone tool, a core of hard stone with specific flaking properties was stuck with the hammer stone. So, shaping the tool to produce required output. See, in the early days, the part was a product. They made a sword, a part, a product. Today, what we do is we do lot of automation. We do lot of mechanisms. So, we try to give energy in one side and try to do multiple things. So, in those days, when they were trying to focus towards manufacturing, they were more focused towards a part to be made as a product which will be made from a single tool. The tool earlier days was stone, and subsequently came the other metals into existence. So, examples of ancient manufacturing: a flint stone core for making blades in Negev, Israel, and a large bronze age sword, dagger blade, now on the display of National Archaeological Museum in France. You can say this is a tool which is used. So, when we try to look into manufacturing, the manufacturing process is generally classified into 6 different types. Constant volume method, that means to say the starting material and the ending material, the starting raw material and the ending product should be almost the same. So, those things are called as constant volume methods. Material shaping deformation, so wherein which the raw material shape is changed from one shape, one dimension to another, but the volume of the material used at this stage is also constant. For example, when we try to make chapati, we try to make a roll, a ball of atta, then we try to smear it or spread it and make it flat. A shape and size is changed into a different shape and size. Here it is again a constant volume process. The raw material which is in a ball form is now converted into a flat smeared chapati. So, that is a constant volume where the material shape is deformed. Subtractive process, wherein which we try to carve out the unnecessary thing from the raw material and try to make an output. For example, you are trying to chisel a statue from a stone. You have a big huge chunk of stone. You try to chisel by using a tool, we start removing. So, it is material subtraction process. Material joining process is you make small pieces, you assemble them to get an output. For example, you want to make a building. So, what you do is you try to have small amount of bricks which are placed one after the other above each other. A unit block is replicated and assembled, you try to make a structure. So, that is material joining. Then polymer is a process where exhaustively it is used for blowing or injection molding. You look at a plastic chair, or you look at a water bottle, you look at a syringe tank, it's all made out of polymer material. So, predominantly here we use molding, injection molding process. So, molding methods. And the last one is additive manufacturing process. Additive manufacturing process and joining process looks to be same, but here the material which is added layer by layer by layer to make an output is material addition. So, basically manufacturing process can be classified one among the 6. For making an output, you can use combination or you can use hybrid also. So, the best example for constant volume process is casting. So, casting is nothing but you think of a die or an ice cube tray wherein which you pour water in it and keep it inside the freezer. So, what happens? The liquid is converted into a solid. Because of the temperature difference which is there, the temperature is extracted and then the water is converted into a solid. A liquid gets into a solid shape. This is casting. So, when we try to do for a metal, what happens is we try to take it to a higher temperature. So, very high temperature like 500 degrees, 600 degrees, 800 degrees. So, we try to melt the metal and take it to that temperature. Now, pour it into a die or into a mold. When you pour it into a mold, you can't directly pour it, because when you directly pour it, there can be a choking. So, we have to uniformly allow it to flow and then go to the mold. So, what we do is the ladle is used to pour. The liquid metal gets into the gating system. So, they have a sprue which is used to make the flow uniform. Then there is a runner. This runner leads to the mold area, and when you exactly pour the required material, there can be sometimes irregular flow. In order to avoid, what they do is they always try to pour excess material. The excess material whatever they pour is now taken away through this riser, or the solidification happens because liquid into a solid, solidification happens. Maybe the flow of material is not sufficient enough to cover the entire area. So, we try to pour some excess from this riser which gets into the mold and fills it up. So, this is a process where it is a constant volume process. What you pour, what it gets solidified will be almost the same. So, the process is called as casting. The raw material are heated up to the melting point, so that the raw material changes its shape and phase, becomes a molten state. The molten form of the material is filled into the mold cavity, so that the molten metal is solidified in the mold cavity and the shape fabricates onto the mold cavity. So, aluminum can be done, copper can be done, brass can be done, cast iron can be done, steel can be done. There are several things which can be done. So, if you try to see the classification of casting, shape casting processes you have expendable mold and you have permanent mold. What are they? The mold whatever you try to make, while taking the product out, you break it. For example, if you try to pour something inside a pottery, it gets solidified, and once you want to take the component out, you break it open. So, that is called as expendable. If you do not want to, the ice cube tray is a permanent mold. So, here you can have a permanent pattern. We will see what is a pattern and all later. So, permanent pattern, expendable pattern, semi-permanent, semi-permanent pattern, and then you will see this is permanent mold. So, these are the way they are classified. When we look at the shaping process, as I told you, I gave you an example of chapati. The chapati, you make a ball and then you split the ball and then you flatten it through a bale or a roller. So, you can see there the volume is constant, the shape and size is changed. So, here in material shaping deformation manufacturing, in shape deformation manufacturing, the shape of the raw material are deformed by applying compressive force, tensile force or shear force beyond the elastic limits. I hope you remember in the first series, we presented a stress strain graph for each of the material and we talked about elastic region, plastic region. So, it has to cross the elastic limits. The material plastically deforms due to the action of shear stress induced in the material. So, this process is called as forming. If it happens for a metal, it is called as metal forming process. There are several examples of metal forming processes. They are nothing but bending of a pipe, then rolling of a sheet, drawing of a wire, deep drawing of a cup or a tumbler, which you use it for drinking water, a deep drawing cup. So, these are some of the processes which fall under material shaping and deformation manufacturing. So, the classifications under shape deformation manufacturing process are, so you can have forming. This forming can be bulk forming, this can be sheet forming, and this can be powder metal forming. Okay. Here bulk forming, we will have primary operation and we can have secondary operation. In sheet metal, we can have, we will write down the process exactly, deep drawing, blanking, punching. These are some of the processes. You have many more processes. In primary operation, you have cast ingot, such as rolling, pipe manufacturing, etc. Secondary operation is forging, next is drawing and many more, etc. So, when you go to powder, it is powder forging, it is powder extrusion, etc. Right. So, if you look at it, the bulk forming, sheet forming, these are basically talking about the material shape and size. If the volume is large and the area is small, it becomes bulk. If the surface area is large and the volume is less, so or the width or the thickness is less, then it forms under sheet. So, if you take various shape deformation processes, they are classified as the following. Then let us look into subtractive process. In subtractive process, the material is removed from the starting material. The material subtraction technique, the materials are removed from the raw material in the form of chip or powder. The workpiece can be rotated or the tool can be stationary, the workpiece can be rotated. It is basically a relative motion between the two plays a very important role. And in the tool, we can have a single point or a multiple point cutting tool to remove material. And apart from this, you can also have a laser. When it hits a surface, the material evaporates, or you can chemically etch and remove the material. So, all these processes are material subtraction manufacturing processes. The names which are given are milling, which is a multi-point cutting tool process; drilling, it is a 2-point cutting tool process; facing, a single point cutting tool to make a flat surface; turning, to reduce the diameter using a single point cutting tool. So, all these things are different manufacturing processes. When we talk about material subtraction manufacturing process, you will have machining. This is machining operation. So, this is rotating type, and this one is reciprocating type. Okay. In rotating type, you have two things. One is rotating tool, the other one is rotating workpiece. In reciprocating, you can have reciprocating tool and reciprocating workpiece. Okay. The processes are milling, drilling, etc. Rotating workpiece, turning, knurling, grooving, etc. When we talk about reciprocating, we talk about shaping and slotting, etc. In reciprocating tool, we talk about planing. Depending here, if you look into it, depending upon the mechanism, like depending upon the relative motion, rotary type or reciprocating type, you classify the machining process or machining operation. Next is joining. So, in material joining process, there can be a joining between two similar materials or dissimilar materials. They can join without a filler or with a filler. That means to say, a filler can be deposited and two pieces can be joined. A filler can be deposited, or this is A, B, or you can join A and B directly without a filler. The material is joined by in such a way that they may or may not destroy the base material. There are several processes wherein which some of them listed here are arc welding, gas welding, soldering, bracing and friction welding. These are some of the processes. So, wherein which there is a high temperature used and then two base materials are joined. If they cannot join, we put a melt a filler and then join. So, these are some of the material joining processes. So, if you want to look at their classification, we have welding process, gas welding, arc welding, resistance welding, solid state welding, then we have thermochemical welding, and then we have radiant energy welding. These are the different types of welding processes. So, we will see them when we go in through the course. We will try to see many of them and understand the process parameters, their advantage, difficulties, all those things. The next one is polymer based. Polymer based is polymer molding process. You have here we have demonstrated an injection molding process. There are polymer pellets. It can be in a solid powder form. It is passed through a barrel where there are 3-stage heating. So, the polymer when it passes through these heaters will get converted from a solid state to a semi-solid state, and then because of the screw which is moving towards in, the polymer is pressurized and injected into the mold to get the required feature. In this kind of manufacturing process, so this is the mold. So, here what you see here is the mold, right. So, in this kind of manufacturing process, the polymer material, small granules or pellets are put in a hopper, and then this moved forward through the barrel in the presence of heater. It is moved inside, and then the polymer comes here, it is injected. After sufficient heating, the pellets granular are converted into a molten state, and then the molten form is injected into the mold. So, there are several processes which fall under them. Two such processes which we have taken is injection molding. This process which is displayed here is injection molding. So, when we try to look at classifications, we can have vacuum forming, rotational molding, compression molding, extrusion molding, blow molding and injection molding. These are some of the classifications of polymer processes. Vacuum forming means vacuum is used wherein which you form a shape given on the polymer. Rotational molding means you try to put the polymer into a cylinder, you rotate it and get an output. Compression is you put it between two flat plates, a polymer, melt, and then it is making into a shape. Extrusion is like you push it through a die, you extrude and get like a wire form. Blow molding is a bottle made, the raw material is kept and then it is blown, air is blown to get the required output. Injection molding is the example which we saw till now. The advanced manufacturing process, in some applications where high precision and accuracies are primarily required, advanced manufacturing process also come into existence. In advanced manufacturing processes, here we also call them as unconventional machining process. Here we use high energy source. It can be ultrasonic vibration, it can be light which is heating a source in, and then it can be a chemical which is used for machining, or between two electrodes there can be a spark which is happening, right. So, all this process, the tool is no way harder than the workpiece. In the normal conventional, the tool should be harder than the workpiece. So, in advanced manufacturing process, some examples are electrochemical machining, electric discharge machining and ultrasonic machining. So, we can focus on this. So, non-traditional machining processes. So, here you can have mechanical based, you can have thermal based, you can have chemical based. In mechanical, you have USM. These are the processes. We will see them in detail. Ultrasonic machining process, water jet machining process, abrasive jet machining process. In thermal, you can see EDM, laser, ion beam machining process, laser beam machining process. Then you can have photon beam machining. In chemical, we have electrochemical machining and you can have chemical machining. Okay. So, these are some of the classifications in advanced manufacturing processes. the last one process is material additional manufacturing. So, here predominantly it talks about additive manufacturing. So, here the starting material can be a powder base, can be a solid base, or it can be a liquid base. When there is a powder base, we will try to use melt processing or sintering process or binding process to convert the powder form into a finished product in the presence of an energy source. So, a laser power can be used, or an electron beam can be used, or a binder jetting can be used. When we take a solid as a process, you can try to have laminated process. So, you can have ultrasonic additive lamination or laminate object molding. So, when we are trying to talk about extrusion process, you can try to have, if it is a wire form, it is fuse deposition process. If it is a liquid form, it is polymerization process, SLA and DLP. So, what are the different steps which are involved in material addition process? In material addition manufacturing, the material is added layer by layer, with wherein the data of the layer is captured from a CAD model, which is generated through a solid modeling software. So, the steps which are involved are: you design an object, then you try to slice and create an STL file, then you try to print them layer by layer using a machine or an energy, then you do post processing, you try to get the shape of the product whatever you want. So, these are the classifications of material additive manufacturing process. To recap what we have studied till now, we have understood what is manufacturing and the excellency of manufacturing, the application of manufacturing, what are the 6 different types of manufacturing, and in each of them what are the major classifications. We will try to study in depth during the course. But before getting into different kinds of manufacturing processes, first let us have a small understanding of material and then jump into manufacturing processes. These are the reference material which we have used. Thank you very much.